Okay, in this video we're going to look at free response 2013 question number 4 through 6. Okay, question number 4 was a chi-square test of independence. So I'm looking at a 4-step process here, with each step earning an E, P, or I, which is kind of generous on the AP rubric. Usually it's E or I for inference questions. So I saw the word of associations. That tells me a chi-square test of independence because I have one random sample and 2 categorical variables. So the hypotheses, the null, age group, and if a person eats greater than 5 fruits and vegetables a day are independent. The alternative, age group, and if a person eats greater than or equal to 5 fruits and vegetables a day are not independent. This could also be is not associated and is associated, which you'll see in the scoring guideline. Okay, so as far as grading that goes, part 1. Essentially correct if the hypotheses are both stated with at least one in context. We're good to go right there. So this is going to be essentially correct. Part 2, or step 2, as you're going to see in the scoring guideline, is your conditions. And what I need to have here is 3 components. Identify the test in terms of the name, verify random sampling, and verify your expected counts are greater than or equal to 5, or greater than 5. So, I've stated it's a random sample, or they stated it was. The counted data, we have counts of people, and I need to communicate to the AP reader all these expected counts, which I've done so here, all of which are greater than or equal to 5. I have my closing statement here, where I've named the degrees of freedom, and that it's a chi-square test of independence. So I've met those 3 criteria for step 2. This would earn me essentially correct. Step 3, the mechanics. Looking at the scoring guideline here, what I need to have is the correct test statistic and p-value or critical value. All right, so this is the correct test statistic. I need to show the observed minus the expected squared over the expected. You'll notice I've rounded these expected values. I need to show at most 3 formulas. My test statistic is 8.983. I did chi-squared CDF, or actually I got this from the chi-square test on the calculator to get my p-value 0.011. I've done those 2 components correctly. Therefore, I've earned essentially correct. In the last step of this problem, I'm going to be writing up my conclusion here. So let's take a look at that. All right. For step 4, in order to earn credit here, we need a correct conclusion, justifying the conclusion based on linkage between the p-value and the conclusion, and the conclusion is stated in context. All right, so what I have is, since the p-value 0.011 is low at the alpha equals 0.05 level, we reject the null. There's a linkage. We have strong evidence that age group and if a person eats more than 5 fruits or vegetables a day is not independent. So I'm talking about evidence for my alternative. And then anytime we reject the null for a chi-square test, I need to talk about why. What was the biggest difference between my observed and my expected values? And put that into context. So it looks like people 55 and older are more likely to eat their 5 servings of fruits and vegetables a day because we observed more than we expected. We observed 3,692 people who didn't, and we expected 3,751. All right. So I believe I've hit the 3 criteria needed for my conclusion. That would give me an E. Grading on this, there's 4 parts. An E is worth 1 point, a P is worth half a point, I is worth 0. I'm going to sum those up. I have 4 E's on this question. Therefore, that's going to earn me a 4. Let's take a look at question 5 next. Okay, in this question, we talked about this a little bit in class. In part A, it looks like it's an inference question, but as we kind of dug a little bit deeper, we realized that it's specifically asking, can I draw this conclusion? So I'm looking at the difference between an observational study and an experiment. This is an observational study because no treatment was imposed, so no, I cannot conclude cause and effect. I could only conclude there was an association between meditation and reducing blood pressure. So if I take a look at the scoring guideline there for question 5, all right. No, it's not reasonable, and it's because it's an observational and it's not an experiment. So that's their model solution. Okay. So you need to say that a cause and effect conclusion cannot be justified and provide one of these two explanations: that it wasn't an experiment because there was no treatments imposed, or talk about the people who meditated could differ from people who didn't on some other factor associated with blood pressure. So I hit this first bullet here and said no, I could not do a cause and effect conclusion, so this would earn me essentially correct. In part B, we want to figure out why it's not reasonable to use a normal model for the sampling distribution. Well, I have a two proportion z-test if I start thinking about some of these conditions here. One of them is the success failure condition. When I checked that here, this is not met, and it's not even close to being met. They said of the 11 men who meditated, 0 had high blood pressure, and of the 17 men who didn't, 8 had high blood pressure. So that's my number of successes in each group. So I have 0 successes and 8 successes and 11 failures and 9 failures. 3 of these 4 numbers are not greater than or equal to 10. So I cannot use a normal model because my success failure condition has not been met. In essence, my sample sizes are not large enough. As far as scoring this goes, indicates that at least one observed or expected count is too small and indicates one of the following 3 components, just one of these 3. So states that the numerical value is not large enough, clearly identifies the count using words, or correctly compares this to a reasonable boundary. And you'll notice that I did that to the 10. Okay, so this is going to earn me essentially correct. Now take a look at Part C. I love Part C. This is something the AP exam has started to ask a lot more recently, and I think there's a chance that it would be on this year's AP exam as well. Basically, they're creating a simulation, and you're using your p-value. You're getting a p-value based on that simulation. So what I need to do is I need to look at the difference between my statistics. Well, 0 out of 11 of the men who meditated had high blood pressure. 8 out of the 17 who didn't had high blood pressure. I'm going to subtract these in my calculator and get that negative 0.4706. So this p-value, looking at the problem, they said they simulated 10,000 times the difference between my sample proportions. Well, 0.47, something that or more extreme, only came up 76 out of 10,000 times. That is extremely unusual. My simulated p-value is 0.0076. So I'm drawing a conclusion based on that. So since my simulated p-value is less than alpha equals 0.05, we reject the null. There's strong evidence that the true difference in the proportion of men meditate minus don't, who have high blood pressure, and I forgot a part here, is, and I'm looking at my alternative, is less than 0. Is less than 0. Okay, taking a look at the scoring guidelines here. Essentially correct if the response provides evidence that the difference in the sample proportions was calculated, I calculated that, and uses the results of the simulation, and includes the following 2 components. States that the value is less than or equal to negative 0.47, or unlikely, comparing this to your significance level, which I did, and then draws a conclusion in context, which I did. So this is going to earn me essentially correct. Taking a look back at the scoring guidelines, I have 3 essentially corrects. That's going to net me a 4 on this question. Okay, transitioning to question 6, your investigative task. And this is the one that's weighted significantly more. Your goal on this question is to earn at least a 1. So starting with question A, compare the distributions. So I'm thinking of the word cost, I'm thinking about center, unusual features, shape, spread. So as I'm going through this, take a look at the scoring guidelines, what they're looking for. So section 1 consists of part A. Well, part A is just part A. So there's 3 components they're looking for. If you haven't noticed the theme, they're always looking for 2 or 3 components, it seems like. A comparison of the center, a comparison of the variability, that's your spread, and in context. So really I'm looking for center and spread. I can't really talk about shape That's why shape's not listed here. And then I have no real unusual features. So you'll notice what I did here is I said typhoons occur with a greater frequency in the Western Pacific than the Eastern Pacific. I'm using a comparative statement, and I can see that pretty obviously in the line plots. That's me talking about center. There is more variation in the frequency of the typhoons in the Western Pacific than in the Eastern. And you can see that there's more fluctuation year to year in the Western than there is the Eastern, which appears a little bit more steady. So I've hit those components there of center and spread, and I've put that into context. That would earn me an E. Now, section 2 for the grading consists of part B. So in part B here, what they're looking for is 2 components: the overall trend for the Western Pacific and the relative constant or slightly increasing trend of the Eastern Pacific. Talking about one of those 2 will earn you partially correct. So I said that the Western Pacific in general saw a decrease in the number of typhoons from 1997 to 2010. And the Eastern Pacific had a relatively consistent number of typhoons with perhaps a slightly increasing trend from 1997 to 2010. So I've hit both of those components that they were looking for. That would be essentially correct. Now, part C we kind of talked about in class as well. This is one of those obscure things that we've never talked about, that we never learned, that they're going to plug in, or that they're going to ask you in a question 6. And as we're doing this, I'm realizing I made a horrible mistake on this question, which you're going to see in a moment. And I guess this is a good learning experience and kind of embarrassing at the same time. All right, so I'm calculating a 4-year moving average. All right, I'm taking the previous 4 years to calculate that moving average. So what I should have done is take these 4 years and find the average of those 4 to get this number. What I realized that I did in my calculation is I took these 4, not years, I took the 4-year moving averages and calculated their average, which immediately is going to be incorrect. But looking at the grading, something this simple is usually paired with another part, and you can see section 3 consists of parts C and D. So when I'm looking at this, there's 4 components: shows the appropriate calculation and has the correct value. That's really, both of those are from part C. And then in part, all 3 of these are from part C. The calculated value is correctly placed in the table. So is obscure and tiny of a detail as that is, answer what they're asking. They tell you to write it in the table, write it in the table. And then this is going to come from part D. Did you place it correctly in the graph? Okay, so I don't have the appropriate calculations. I don't have the correct value. I was doing this on a separate sheet of paper, so I did not put it in the table. But you'll notice on my graph, I appropriately placed my value. So I've done 1 out of the 4 things correct here. This is an I. And something like this, they're giving me a point pretty much. They're like, here, take this point. Like something like this, you need to earn a point on. Again, your goal is 1 point here. That would be a great opportunity. So for parts C and D, I've just earned an I. Okay, so last part is section 4, which comes from grading part E. Okay, so section 4 is from part E. And if we take a look at part E and grading that, there's 3 components. Shocking, 3 components. It's always 2 or 3, it seems like. Okay, 3 things we're looking for. I want to mention the overall trend when I'm looking at the averages in at least one region. Correctly identify some characteristic that is less apparent, and then link one of the 2 previous components to the time plot in this specific question. So let's take a look at what we have there. And I might need to come back to their solution. All right, so here's what we have, or here's what I have. So something that I said was more apparent is that the number of typhoons in the Western Pacific was decreasing and increasing in the Eastern Pacific. Okay, these solid lines, it's more apparent. This is obviously decreasing. This is showing a slight increase. In part 2, I said it's less apparent that there's a great deal let me try this again. There's a great deal of variability year to year in both the western and eastern Pacific frequencies of typhoons. I don't see the peaks and valleys that in the dash graphs, or I'm sorry, in the solid graphs. It's much more consistent. So taking a look at what they have here. Part 1, the overall trends across this time period were more apparent. So that's talking about the trends, and we have decreasing in the west and a slight increasing in the east. And then part 2, the year-to-year variability. So you'll notice I discussed both of these things. So here, this is going to earn me an E. So at this point, I have 3 E's and I have 1 I. There was 4 parts. So E's are going to be worth 1 point, P is a half, I is 0. I have 3 points. This is going to earn me a 3. All right, hopefully you guys found this helpful. We'll discuss tomorrow, and happy reviewing.